morning, Iona. Today is December 14th, date. Oh, this is Gale Force Live. Oh, it's my chem project? Oh, my fault. Why do atoms form bonds? Atoms form bonds to become stable. To become stable, they must have 8 or 0 electrons. This is called the octet rule. Anions and cations. Cations are positively charged ions that want to bond with anions, negatively charged ions. Positive and negative ions attract. Therefore, when they attract, they share their electrons. When ionic bonding, they interchange electrons, therefore leading back to the octet rule with 8 or 0 electrons. Ionic compounds take electrons rather than sharing them, like covalent compounds. This allows ionic compounds to be much stronger than covalent compounds. Not only are ionic compounds stronger, they also have higher melting points, higher boiling points, and they can conduct electricity when they're in water. Ionic compounds form crystal-like substances. When ionic compounds are created, they join into a mesh of a pattern of positive and negative ions. Now, ionic bonding is not the only type of bonding that we've used. There's also something called covalent bonding. In this bonding, rather than electrons being taken, they are shared. This type of bonding, since it is weaker, it is less soluble in water, it has a lower melting point and a lower boiling point, and when it is soluble in water, it does not conduct electricity well. To ionic bonds. Covalent bonds also follow the octet rule, as they must have 8 or 0 electrons. Now, they don't have to actually have the electrons. It could be shared, and that still counts to follow the octet rule. Covalent bonds come in single, double, or triple bond. The triple bond is the strongest bond, and every bond shares 2 electrons. So if you have a single bond that shares 2 electrons, double bond shares 4 electrons, triple bond shares 6 electrons. Metallic bonds are bonds in which one or both of the bonded substances are metals. Metals are malleable, ductile. They are magnetic, usually, not always, and they are good conductors of electricity and heat. This is why when you're cooking, you very rarely see a metal handle. You always have rubber around it, because rubber is not a very good conductor of heat. Electronegativity is an atom's strength in its ability to take another atom's electrons, and it helps with any kind of bonding. And the bigger the atom, like the bigger the atomic radius, the less electronegativity it has. The atomic radius is the largest in the bottom left corner of the periodic table. Therefore, the bottom left corner of the periodic table is also the least amount of electronegativity. As you go to the right and go up across the periodic table, the more electronegativity the atoms will have. Polar bonds have an unequal distribution of the valence electrons. Electronegativity can cause this is if one electron has a lot more electronegativity than the other one. Therefore, this one would have more electrons, this one would have less, creating a polar bond. How to name formulas and compounds. So here we have NO2, which is nitrogen dioxide. And this is called nitrogen dioxide. So we have two oxygens. So oxygen di is two. So nitrogen, one nitrogen, two oxygen, nitrogen dioxide. That's how you get that name. Next we have water. This is H2O, and water is the name of H2O, but if you want to get into technical terms with chemistry, you would call it dihydrogen monoxide. And this you call it because you have two hydrogens, one oxygen. So di is two, mon is one, dihydrogen, two hydrogens, monoxide, one oxygen. Next we have salt, which is NaCl. This is the first ionic compound of the two that we're going to do. And NaCl turns into sodium chloride, sodium Na, chloride Cl. Sodium chloride salt. The last one we're going to do is magnesium bromide. You have one magnesium and two bromine. Bromide shows there are two. Magnesium is just the name of the element, therefore there's just one. So magnesium bromide.